What's up? I'm Vin, and I'm going through the 2024 New York Grade 7 math test, and I'll leave a link to a copy of this test in the description below. Now let's get started. Question 1, a store sells packages of butter. The table below shows the cost in dollars for different numbers of packages of butter. So here's the cost of butter. We have number of packages and the cost in dollars. And we want to know what is the cost per package of the butter. So for this question, what we could do is we could just take any pair here. Let's say I look at the first pair that we have 3 packages of butter costs $9.75. And we could set up this ratio here. We could say it's $9.75 for 3 packages of butter. Okay, so for 3 packages. So we want to know how much is it for 1 pack, okay? And I'll just abbreviate packages like this. So for this, all we have to do is divide 975 by 3. And you can use a calculator to do this division, or you could do the long division on the side. But look, if you do get a calculator for the test, which you can use a scientific calculator for both sections, it doesn't hurt to at least check your answer with the calculator. But I'll go over long division. So 3 goes into 9 3 times. We have 3 times 3 is 9. So we have no remainder here. But then we bring down the 7. And notice the decimal is here, so I'll just move it up. And 3 goes into 7 twice. 2 times 3 is 6. So I subtract now. And I have a remainder of 1. I bring down the 5, and 3 goes into 15 5 times. 5 times 3 is 15. So when we subtract, we have no remainder. So this simplifies nicely to 325. Okay, so it is 325 for a single package. Okay, so 325 for 1 pack of butter here. And this is going to match up with choice B. Question 4, a farmer plants 4 rows of seedlings. The first 3 rows are equal in length, and the length of the 4th row is 19 yards. The total length of the 4 rows is 61 yards, and we want to know what is the length in yards of each of the first 3 rows the farmer plants. So for this one, what I would do is just draw out the 4 rows. So we have the first 3 rows here, and they are all the same length, and then the 4th row they told us is 19 yards. So what I'm going to do here is label that 4th row 19, and then the first 3, I'm just going to call all of them X. Because we don't know what the length of each of these rows is, but we do know that they are all equal in length. So that's why I'm going to call them all the same variable. And now if I want to find the total, I would add all of these up. I would do X, and then I have plus another X, and then the 4th row is 19 yards long, so I'm going to do plus 19. And I'm going to set this equal to 61 because we were told here that the total length of the 4 rows is 61 yards. So now we just combine like terms. X plus X plus X is 3X. And then we have plus 19 equals 61. And now we just have to do a little algebra here. The opposite of plus 19 is minus 19. So I'm going to keep doing the opposite operation until X is by itself. So I'm going to do minus 19 on both sides. And that's going to get the 3X by itself. So 19 minus 19 cancels. And we have 3X equals. And for this one, we can use a calculator, but I'll just review a long subtraction here. So I borrow 11 minus 9 is 2, and then 5 minus 1 is 4. And then I have 3 times X equals 42. I'm just going to move this over. So how do I get rid of times 3? The opposite of multiplying by 3 is dividing by 3. But the golden rule of algebra is whatever I do to one side, I have to do the same thing to the other. So I have to divide both sides by 3. 3 divided by 3 cancels, and then X equals, if I do 42 divided by 3, that's 14. Okay, so the length of each of the first 3 rows is 14 yards. Now, if you really had to here, what you could do is you could just write all of these values in, and you could check your answer just by adding all of this up. So if you put 14, 14, 14, and you add all these numbers, you are going to get 61. So choice A is definitely our answer. Question 5, on average, ocean temperatures around the world range from negative 2 degrees Celsius to 32 degrees Celsius. And we want to know what is the difference between the 2 ocean temperatures. Now, if you just know to do 32 minus negative 2, that's excellent, okay? You just do this and you're going to get 32 plus 2, and that simplifies nicely to 34. So our solution here would be choice B. If that didn't make sense what I just did, well, think about this in terms of a thermometer. So here we'll say is 0. Negative 2 degrees, I'm going to put down here like this. And then this distance up here, we're going to call 32. So if we're going from negative 2 to 32, notice that we have to go up 2, and then we have to go up another 32. So that's where the 32 plus 2 is coming from, giving us 34. And now the units here, we're talking about degrees Celsius. So our solution is 34 degrees Celsius. Question 7, Mr. Moore collected data from his 6th grade class on how many minutes they studied for a test. The dot plot below shows the number of minutes each student studied. And we want to know which statement about the distribution of the data is true. So here we have this dot plot, and we are just going to go through the answer choices. We want to know which one is true. So choice A, the distribution is symmetrical. This is not true because if I were to drop down a line like this at about the halfway point, you could see that this line does not act like a mirror. If it did, I would have an equal height immediately to the right of the line like this, and then I'd have to bump this one up here like this. I'd have to bump this one up here like this. And then I need this value, like let's say way out here like this. Okay, that would make it symmetrical, but that's not the case here. That's not what we have. So that's why A, we could eliminate. Okay, A is not our answer. The distribution has a range of 25. So that you take the biggest value in the dot plot, and the biggest value where there is actually an entry is 45, and you subtract the smallest value is at 5, and this distribution actually has a range of 40, not 25. So B is out. The distribution appears to have an outlier. This is the answer, and an outlier is a value that is far away from the general values here. Okay, so this 5 is definitely out of place because if you look at this central cluster here, we have values going from 20 to 45. So this value here is 15 to the left of the smallest value of this cluster. So this is kind of way out there. Okay, so that's why we call this an outlier. It's on the outside and it's looking in at the cluster like this. Okay, so then choice D, why is this one not true? The distribution has a cluster from 25 to 35 minutes. Well, from 25 to 35, there's definitely a cluster, but the cluster goes even, a wider range here. It actually goes from 20 to 45. That's where the values here are clustering together. So that's why D is out, and choice C is definitely our answer. Question 10, Victoria has a movie subscription. She pays an annual membership fee of $24 and a fee of $4 for each movie she watches. Which inequality can be used to determine the total number of movies M Victoria can watch if she wants to spend less than $100 per year? So for this one here, we have to pay very close attention to the difference between the $24 and the $4. The $24 is a fixed amount. Victoria pays this once per year, and this does not depend on how many movies Victoria watches. But the $4 is the fee that Victoria pays for each movie that she watches. So that's why we're going to start off with 4M plus 24, because this is how much money Victoria spends. Okay, so this is the money spent here. It's $4 per movie, so we do 4 times M, plus the annual fee is $24. Now, for this part, we have to pay very close attention. Victoria's goal is to spend less than $100 per year. So if we want the money spent to be less than 100, we just have to put less than 100 here, and our answer is going to be choice B. Choice A is no good because the values here are mixed up. We wouldn't multiply the number of movies by the membership fee, so that's why A is completely wrong. Choice C is almost correct, but this would be true if Victoria wants to spend at most $100. Then her money would be less than or equal to. The money spent would be less than or equal to in this case. If Victoria wants to spend at least $100, she has a goal to spend $100 or more, then it would be greater than or equal to. Okay, so that's why these two answer choices are no good. Choice B is definitely our answer. Question 11, the regular price of a shirt is N dollars. During a sale, the shirt is discounted by 15%. Which pair of expressions includes 2 correct ways to represent the price in dollars of the shirt after the discount? So for this one, we have to know how to convert 15% into a decimal. So 15% means 15 out of 100. And 15 out of 100 could be expressed as a decimal if we write 0.15. This means 15 hundredths. So from here, let's think about this. The price of the shirt is N dollars. So if we want to take 15% off, then what we do is we subtract 15% of the original price. So I'm going to take 0.15 and I'm going to multiply it by the original price of the shirt. And then I'm going to subtract that from the original price of the shirt. And this is going to give us the discounted price. So we're looking for n minus 0.15n, and that narrows it down to two answer choices. So it's either B or D. And then from here, we just have to know how to do a little bit of algebra. When we are combining like terms, we have to just add or subtract the coefficients in front. Now, the invisible coefficient in front of n is going to be 1. So I could think of this as 1n minus 0.15n. And then if I just do 1 minus 0.15, this you could use a scientific calculator. This is going to work out to 0.85, which shows up in both answers. However, we just have to make sure that the variable carries down. If we do 1n minus 0.15n, we're going to get 0.85n. So choice D is our answer. Question 13, which expression is equivalent to, and we have this long expression here. So we're going to start by using the distributive property. We're going to send this term through, and we're going to send this term through over here. So first we have 3.6 times x, and we could write that as 3.6x. And then we have a positive times a negative, so we're going to get a minus, and then 3.6 times 5 is 18. This you could just use a calculator, or you could go off to the side and do 3.6 times 5. But remember, you do get a calculator, so I would at the very least check the work you do by hand. So here we have 5 times 6 is 30. We carry the 3. And then 5 times 3 is 15 plus 3 is 18. So now I look and see that I have one decimal place that I ignored. So in my final answer, I just have to pay one decimal place back. So that's where the 18 is coming from. And now I'm going to distribute the 2.5. 2.5 times x is 2.5x. So I'm going to say plus 2.5x. And then I have 2.5 times 4, and that's going to work out to 10. So I have plus 10 at the end. And now here I combine like terms. I'm going to do 3.6x plus 2.5x. So the math that I'm doing in my head or off to the side in the calculator is I'm adding these two numbers here. And this is going to give us, we have 6 plus 5 is 11, carry the 1, and I get a 6 here, and I drop down the decimal. So we're going to have 6.1x. So right away, I could see these two answer choices are out. And now from here, we have negative 18 plus 10. And if I do negative 18 plus 10, the absolute value of the negative number is greater. So the negative is going to win the battle here, and it's going to win by 8. Okay, so that's kind of how I imagine doing addition with integers in my head. Is I just think of this as a tug of war between a negative and a positive. So it's negative 18 versus 10. And I think, all right, who would win this battle? Well, this is the bigger number. If the negative wasn't there, it would win by 8. So that's why it works out to negative 8. Okay, so however you get to the answer, great. If you could just see a number line in your head and that helps you, you could always go like this and say, all right, let's say 0 is here, and then I'm at negative 8, negative 18, not necessarily to scale. So when I add 10, I'm going this way like this 10 units, and I'm landing at negative 8. But whatever actually works for you, that's the one you use here. But either way, we're going to get 6.1x minus 8. Choice B is our answer. Question 14, a teacher records the test scores for the students in her class. The results are shown in the box plot below. And based on these data, what is the interquartile range? So this question has the potential to be very easy if you know the anatomy of a box and whisker plot and you know what it means to find the interquartile range. So the interquartile range, you're doing Q3 minus Q1. And for any box plot, the beginning here is Q1. So this represents Q1. The end here at the end of this, they used to call this box and whisker plot. I haven't seen it called that in a while, but because these kind of look like whiskers, but I do miss the old way they used to name it. But this is the minimum value because it's all the way to the left. This is the maximum value. And then here, this is either we could say Q2 or we could call it the median. Okay, so this is the median over here. And then at the end of the box is Q3. And then the max is the final value all the way to the right. So if I just have to do Q3 minus Q1, I just have to line this up very carefully. So if I drop this down, notice it's going to line up here. So this would be 76, 77, 78. And then I'm going to subtract Q1. Looks like it's landing here at 67. Okay, the spaces between these numbers, there's 5 spaces, and we're going a total of 5. So that's why we're counting by ones. We could say 66, 67, 68, 69, 70. So I'm going to do 78 minus 67. This I could also do in a calculator, or this is not too bad to do by hand. This difference works out to 11. Choice C is our answer. Question 15, what is the value of the expression shown below? So if you get a scientific calculator, you could just type it in like this. You could say 1/3, and then minus, in parentheses here, I'm going to say 2/3 like this, plus 5 over 7. And then I'm going to close the parentheses. And now one thing to be mindful of, I'm going to say minus, but I just want to let you know 2 1/5 can be expressed as 2 plus 1/5. If you have 2 and a fifth, you have 2 plus another fifth. So when I say minus this mixed number, I just have to make sure that I put parentheses around this, because if I don't write parentheses, it's going to throw the whole question off. And now I press enter, and notice I get -3 point something, something, something. And if I look here, the only answer choice that has a -3 in front is choice D. And if I want to check the decimal at the end, I do 26 over 105, and let's see if it matches. And we do get a match here. So choice D is definitely correct. So with just the calculator, you could get right to the answer here. But I will show you how to do this by hand as well. So if we were to do this by hand, then we have to find common denominators all throughout here. So we just got to take this piece by piece. So I notice here that we have denominators of 3, 5, and 7. So if we're looking for the least common multiple of 3, 5, and 7, well, one way to get there is to just multiply these numbers together. And if I do 5 times 7 is 35, and then 35 times 3 is 105. So the least common multiple would be 105. So that's what I could think of when I'm creating all the denominators that I need here. So if I go piece by piece, the first fraction here, I would multiply by 35 over 35. So I have 35 over 35 times 1/3. And then minus, in parentheses, I have 2 over 3. This one I would also have to multiply by 35 over 35. And then we have plus 5 over 7. To turn 7 into 105, I'd have to multiply by 5 times 3, which is 15. So it helps to know what the other denominators are, because if I'm trying to turn the 7 into 105, I just have to multiply by the other two numbers. And now I have minus. And for this one thing I'll do off to the side first is take 2 1/5 and turn this into an improper fraction. So we multiply. So this is going to be, we have 5 times 2 is 10. And then we're going to add this value here. We're going to add the 1 in the numerator. And this is over 5. So this is 11/5. So now I'm going to rename this 11/5. And this we'd have to multiply by 3 times 7, which is 21. So I'm doing times 21 on top and bottom. So now we have, let's see, 35 over 105. And then we have minus, in parentheses, 2 times 35 is 70 over 105. And then we have plus 5 times 15 is 75. So we get 75 here. Over 7 times 15 is going to give us 105. And now outside the parentheses here, we have 21 times 11. And for this one, you could just use a calculator, or there's a fun little mental math trick you could do. You could do times 10 and then add the numbers. So I do 210 plus 21, and 210 plus 21 is 231. Okay, and this is over 105. But please use a calculator, for situations like that. Don't, try to do too fancy of math at the day of the state test. So now from here, I'm just going to go piece by piece. So now we could simplify. We have 35 over 105, and we're subtracting here what we have in the parentheses. So we're going to do the parentheses first. Just think order of operations. We have PEMDAS, so we're doing parentheses first. So 70 plus 75 is 145. So we're going to subtract 145 over 105. And now we have minus 231 over 105. So now next I would subtract these two. I'm going to do 35 minus 145. And that's going to give us, we're going to have negative 110. So I have negative 110 and then over 105 minus 231 over 105. So without the calculator, this is very exhausting. And if that was a little confusing, what I just did is I subtracted 35 and 145 to get negative 110. And now I have to do negative 110 minus 231. I keep my denominators the same. So now when I subtract these two numbers here, and that's going to give us negative 341. So I'd have minus 341 over 105. Okay, so for this, now I could just simplify this by doing the long division. But just know at any point you do get a scientific calculator. So for the little calculations, you could definitely do this with the calculator. And now from here, I know that 105 is going to get us close to 341 if we multiply by 3. And if I do 3 times 105, that's going to work out to 315. And now I subtract, and I'll borrow here. So we have a 3 left. I put a 1 here. 11 minus 15 is 6. 3 minus 1 is 2. So we get a remainder of 26 over 105. But now I just have to tack on the negative here. So we're going to have negative 3 and 26 over 105. So if we do this by hand, we're still going to get choice D. Question 17, there were 2 movies shown at a theater. A total of 150 tickets were sold for the first movie, and 40% more tickets were sold for the second movie than for the first movie. If each ticket sold for $13.50, what was the total amount of ticket sales in dollars for both movies? So for this one, what I would do is find the total amount of tickets sold and then multiply by $13.50. So for the first movie, there were 150 tickets sold. For the second movie, we were told that there were 40% more tickets sold than were for the first movie. So here, what we could do is we could take 40% of 150. So if I want to take 40% of 150, I can multiply by 40 over 100, okay? Because this is 40%. And now from here, the calculator will do this for us. I could also just call this 40 over 100. I could call this 0.40. So this is the same thing as 0.40, or I could say 0.40. So I could ask the calculator to multiply this and this, and we're going to get 60. If I want to do this by hand, I could cross off this 0 and this 0. I could cross off this trailing 0 and this trailing 0, and then 15 times 4 is 60. But be careful here. They told us that 40% more tickets were sold. So that means that they sold an additional 60 tickets from the 150. So if I do 150 plus 60, that's going to give us, we're going to have 210 after I do all the addition here. Okay, so the second movie, there were 210 tickets sold. So the total, we would add these values together. And let me make that a little bit neater. So the total, we would add together 210 plus 150. And if we add these values together here, we're going to get 360. Okay, so 360 tickets were sold in total. So then all I have to do is do 360 times $13.50. And I could do long multiplication here, but this is going to take a long time considering that we're doing a 4-digit by a 3-digit here. So for this, we'll just use the calculator. So we're going to do 360 times, and then we have 13.50. So we just got to throw in that decimal there, and it's going to work out to 4,860. So we have, once again, the total is 4,860, and this is going to match up with choice D. Question 21, the table shown below represents a proportional relationship between x and y. Which equation represents this proportional relationship? So this formula is really good to know. When two variables are in direct proportion with each other, then that means the variables satisfy this equation y equals kx, and k is the constant of proportionality, okay? So this is the value that we want to find. So all we have to do is just take any x and any y from the table and plug it into this formula to see what the k value is. So from here, what I'm going to do is, let's say I take the first entry here. I have x equals 9 and y equals 2.25. So I'm going to write 2.25 equals k times, and then we're going to multiply that by x is 9 in this case. Okay, I'm just taking one of the entries here from the table. And now to solve for k, I just divide both sides by 9. And we divide by 9 here, and k is going to simplify to, so I could just do 2.25 divided by 9 in the calculator. And if you do this in the calculator, it's going to work out to 0.25. Okay, so this works out to 0.25, and 0.25 is the same thing as 1/4. So I could say that the k value here is equal to 1/4. So then all I have to do is just plug this into the formula here for y equals kx, and I have y equals k is now 1/4 times x. So this is going to match up with choice C. Question 26, Pat uses 2 5/8 cups of sugar for 3.5 batches of cookies. She uses the same amount of sugar for each batch of cookies baked. How much sugar in cups per batch does Pat use to bake cookies? So for this one, we could just set up this ratio. We have 2 5/8 cups of sugar, and this is for 3.5 batches of cookies. Okay, so we have 3.5 batches, but I'll just write the word batch here. And what we're going to do is we're going to find the unit rate, and we set this up right to start because look at how it's being expressed here. We want to know how much sugar in cups per batch. And notice that we have cups on top and batch on bottom. So now we just divide these two. And for this one, we can use a calculator. So if we want to divide these two mixed numbers, what we could do is we could type the first mixed number in parentheses. We could write 2 plus 5/8 like this using the division. And then we're going to press divided by, and we're going to put the second mixed number also in parentheses. So we have 3 plus a half. If you just know 3.5 is 3.5, then you can just divide by 3.5 and that's fine. And we press enter and we get 0.75, which is 3/4. Just know that you could do this. You could do 2 plus 5 over 8. So let's write here 2 plus 5 over 8. And we get this decimal here. And we could just divide 2.625 by 3.5. And this will also give us 0.75. Either way, we're getting choice A. So this is going to work out to choice A. If we want to do this by hand, it's definitely more work. We would have to turn both of these into improper fractions and divide that way. So I would do 2 times 8 is 16, and then 16 plus 5 is 21. So I get 21 over 8 for cups. And then on bottom here, 3.5, I would do 3 times 2 is 6, plus 1 is 7, so I get 7 over 2. And this is for the batches of cookies, okay? So we get 7 over 2 here. And then when you divide fractions, you have to use keep, change, flip. So for keep, change, flip, what we're going to do is we're going to take 21 over 8. We're going to keep this. We're going to change the operation to multiplication, and we're going to flip the bottom fraction to 2 over 7. And the units are going to be cups per batch. So that I'll just write off to the side. And now from here, we could cross cancel. 21 divided by 7 is 3. And then 2 goes into 8 4 times. Or I could just think of this as reducing. 2 over 8 reduces to a fourth. So this is going to simplify to a 4. And notice I get 3 over 4. And the units here are cups per batch. Okay, so this is definitely going to match up with choice A. Question 29, a 7th grade class sells gift cards as a fundraiser for the school library. Each gift card sells for $15, and the library gets 35% of the money earned for each gift card sold. How much money does the library get if the class sells 500 gift cards? So for this one here, what we should do first is find out how much money is earned in total. So the money earned, we're going to take the total number of gift cards sold, and we're going to multiply it by the cost of each one. So we're going to do 500 times 15. So we're going to have the 500 gift cards. We're going to multiply by 15 because each one is going to sell for $15. And now here I could use a calculator, or I could just do 15 times 5 is 75, and there's going to be 2 extra zeros trailing at the bottom like this. Okay, so the money earned is going to be $7,500. And now we just have to be careful here. We're finding 35% of this because the library gets 35% of the money earned. So now 35% we could express as 35 over 100, and we could also express this as 0.35. So now what I'm going to do is I'm going to take 35% of 7,500. So we're going to take the $7,500 and we're going to take 35% by multiplying by 0.35. So we could do 7,500 times 0.35. And here is our solution. So we work this out, and the money donated to the library is going to be $2,625. Our answer here is choice C. Question 30, which graph represents the solution to the inequality 4 minus 4x is greater than 16? So for this one, we're solving for x, and then we have to sketch the solution. So what I would do is get rid of this 4 in front. This is a constant without a variable. So here we could just do minus 4 on both sides of this inequality. So this starts off nicely. We have 4 minus 4 canceling, and then we have minus 4x left on the left side is greater than 16 minus 4 is 12. So now to solve for x, we're going to divide both sides by negative 4 because we have negative 4 times x. The opposite of multiplying is dividing, so we divide both sides by negative 4. But now for this part, we have to be very careful. It's very tempting to say here that 12 divided by negative 4 is negative 3, and then students will just say x is greater than negative 3, and then they choose something like choice B. But choice B is a very dangerous bear trap, okay? We have to be very careful here. When you multiply or divide both sides of an inequality by a negative, the sign has to flip, okay? So the sign here, let's just write this out. The sign here is going to flip, and the reason being we are dividing both sides by a negative. So I'm just going to erase this greater than. The sign flips to a less than. So we're not going to be shading to the right of negative 3. We're going to be shading to the left of negative 3. So notice we have the open circle at negative 3, and all the values to the left are shaded here. So that's why our solution here is going to be choice A. Question 31, what is the value of the expression shown below? So let's type this in. -1.5, I could put a negative here, and then parentheses 1 plus a half. And then I close the parentheses, and then we have plus. In the next set of parentheses, we have -7/8. And then we're multiplying by -3/4. So I do this, I press enter, and notice that I have a decimal that's pretty close to -1, but it's a little greater than -1. So I know it's not A, because A would be a little bit less than -1. You see how this would be -1 and change, but this doesn't even make it to -1, so A can't be it. B is a contender, because this is almost -1, but not quite. It's a little bit to the right of -1, and it's definitely not C or D, so B is it. And if I wanted to double check, I could just do 27/32 to see if the decimals match, and they do. So choice B is definitely our answer. But of course, we should also learn to do this by hand. So something like 1.5, I could convert to an improper fraction by doing 2 times 1 is 2, and then plus 1 is 3, and I keep my denominator 2. So now I could rewrite this as -3/2, and now I have plus, I'm doing a negative times a negative, which turns out positive. So now all I have to do is multiply 7 times 3 is 21. And then my denominator is 8 times 4, which is 32. So here, what I would do is make common denominators. So I'll make space. And what I'm going to do is I'm going to multiply this first fraction by 16/16 so that my denominators match. I get a matching 32. So -3 times 16 is -48. And we're over 2 times 16 is 32. And then we have plus 21/32. So now if I do -48 plus 21, the math that I'm doing in my head is I'm just saying, okay, this is the same thing as negative and then 48 minus 21. So I just take the minus out and I do 48 minus 21 like this. And then that would work out to, I would have 27 on the inside and the minus on the outside. So this would work out to -27/32. And that's why choice B is our answer. So now we're moving on to session 2. We are still going to have a calculator for this part of the test, and we are going to have to do some free response questions where we explain our answers. Question 33, which situation results in a final value of 0? So let's go through these one by one. So we have for A, the total number of pencils Aaron has if he had 12 pencils and bought 12 more pencils. Well, if he has 12 pencils and buys 12 more, then he'll have 24 pencils. So that would not give us a final value of 0. So A is out. For B, we have the total number of blocks Tom walks after walking 6 blocks north and walking 6 blocks west. Well, if he walks 6 north and 6 west, that's a total of 12 blocks. That's not 0, so B is out. For C, the total distance Nicole hikes from a depth of 10 feet below sea level to a height of 10 feet above sea level. Well, if she goes from 10 feet below to 10 feet above, then she's going from basically here -10 to +10. So from -10 to +10, just imagine it's going up. That's a total of 20. So that's not a total of 0. So C is out. So just by process of elimination, it has to be D. But let's see. The total number of cookies Tiffany has if she bought 4 batches of cookies and sold the 4 batches of cookies. So she bought 4 and then she sold 4. So that means she lost them. And she has a total of 0 batches of cookies. So D is definitely our answer. Question 34, Cheryl earns $23.75 babysitting for 2.5 hours. At that rate, how much does Cheryl earn when babysitting for 5 3/4 hours? So for this one, we could set up a proportion. We have Cheryl earns $23.75 when she babysits for 2.5 hours. So I'm just going to say 2.5 hours. 1/2 is equal to 0.5. So this is what we have here. And we want to know how much money does she earn. So how many dollars? We'll say X dollars if she babysits for 5 3/4 hours. So I could say 5 3/4, or I could say 5.75. So now what we'll do is we'll cross multiply here. I'm going to do 23.75 times 5.75, and we're going to set this equal to 2.5 times X. So we're going to have 2.5X equals, and we're multiplying these two numbers. So I'm going to do 23.75 and then times 5.75. And then after we do this, eventually we are going to have to divide by 2.5. So I'm just going to do that now. I'm going to press divide and then 2.5, and that's going to take the answer and divide by 2.5. So 23.75 times 5.75 is 136.5625. And now from here to solve for x, to get rid of the times 2.5, we're going to divide both sides by 2.5. So we're going to go divide by 2.5 on both sides. And now x is equal to, and this worked out to 54, but I'm going to round to the nearest hundredth here because we're talking about money. So we're talking about cents. So to the right of a 2 here is a 5. So we're going to round this up to 63. So we have 54.63, and this is going to match up with choice B. Question 35, 2 line plots are shown below. The first one represents the average cell phone usage per day in minutes of 20 teenagers. The second one represents the average cell phone usage per day in minutes of 20 adults. And we want to know which statement about the 2 data sets is true. Well, one thing that jumps out when we go to the answers is that we're either going to be finding the mean, which is the average, or we're going to be finding the range here. So it's going to refer to, well, the answers depend on either the mean or the range. So let's go ahead and find both of those for the teenagers and the adults. Now, of the 2, the range is easier to find because we only have to subtract the biggest value and the smallest value. So for the teenagers, we could do 620 minus 460. And this we could do by hand, or we could just use a calculator, and we're going to get 160. And if we do this for the adults, we're going to subtract the biggest value and the smallest value. So we do 360 minus 120. So 360 minus 120 is going to give us 240. So just looking at this, the adults, their range is greater. So looking at the answer choices, the range of the data for the teenagers is greater is wrong. We could cross this off. And the range of the data for the teenagers is greater than the adults' range is also wrong. So now that tells us that we're going to be looking for the mean or the average for the adults and the teenagers. And we want to see which one is greater. Well, the fastest way to go through this, we could find the average by adding all of these 20 values up and dividing by 20 and doing that for the adults as well. Or we could look at where these values here are clustering. Notice that the cluster here is occurring between 480 and about 580. That this is where the values are tending for the teenagers. We could even see here that it's between 460 and 620, whereas for the adults, we're between 120 and 360. So the range of scores here are spread out between greater numbers for the teenagers than they are for the adults. So right away, it's looking like the teenagers spend more time on their phones on average. So now we go to the answer choices, and let's see. The mean of the data for the adults is greater. This is right away not it. The mean is going to be greater for the teenagers. But let's see the reason for choice A to see why this is definitely no good. And the because is the data points for the adults are more spread out. That wouldn't have to do with having a greater average. What determines the average is that the scale for the teenagers has greater numbers than the scale for the adults. Okay, we're just talking about generally the teenagers are spending more minutes on their cell phone. So when we take the average involving greater numbers, we're going to have a greater average. So that's why here choice B is our answer. Question 36, there are 140 students enrolled at a school. Of the students that are enrolled at the school, 3/4 play sports. Of the students that play sports, 1/7 are in an art club. How many students enrolled at the school both play sports and are in an art club? Well, let's go through this piece by piece. We have 140 students at some school, and of those students, 3/4 play sports. So we're going to take 3/4 of 140, and this we could just use a calculator, or we'll just do this by hand. So if I do 140 divided by 4, that's going to give us 35. A little mental math trick: when you want to divide a number by 4, just divide that number by 2 twice. So I take half of 140 is 70, and half of 70 is 35. And now 35 times 3 is 105. So this tells us that 105 students play sports. And now what they tell us next, out of the students that play sports, 1 out of 7 of those students are in an art club. So now we could just take 105 and take 1/7 of this. And if we multiply 105 by 1/7, we're really just doing 105 divided by 7. So I'll just do that off to the side, or we could use the calculator. 7 goes into 10 once. 1 times 7 is 7. subtract, you have a remainder of 3. You bring down the 5, and 7 goes into 35 5 times. And 5 times 7 is 35. We subtract, we have no remainder here. So this tells us that 15 students play sports and are in an art club. So choice B is our answer. Question 37, which expression is equivalent to, and we have this expression here. So notice we have to do 17 times 1/3. And when you multiply a whole number by a fraction, you could just do the whole number times the numerator. So we're going to get 17 times 1 is 17, and then we're over 3 times x, and we're subtracting 7 over 2 times x. And the reason behind this, when we do 17 times 1/3, this is the same thing as doing 17 over 1 times 1 over 3. And then we just do 17 times 1 is 17, over 1 times 3 is 3. So this is really what's going on here. But the fast way is just multiply the whole number by the numerator like this. So now what we need to do is find a common denominator between 3 and 2. And the least common multiple between 3 and 2 is 6. So I would multiply this first fraction by 2 over 2, and I'll multiply the next fraction here by 3 over 3. I'm just going to move this over to make a little space. So we're going to do times 3 over 3 for this one over here. And what we're going to have is, I'll turn this into a dot so it doesn't look like an X. And what we're going to have is 2 times 17 is 34, over 2 times 3 is 6. The X tags along. And we have minus 3 times 7 is 21, over 3 times 2 is 6. And then we just tack on the X here. So now we're going to combine like terms. We have 2 X terms here. So at the end, we're going to have an X term, but what we're doing is we're doing 34 over 6. I'll write it off to the side. 34 over 6 minus 21 over 6. And for this one, we just subtract these two numbers. We're going to get 13, but we're over 6. So that is the coefficient of X. We have 13 over 6 times X. And this is going to match up with choice C. Now, one thing, you might be looking at this and saying, wait a minute, this doesn't match directly. But if I do 13 over 6 times X, that's the same thing as saying 13 times X over 6. So either way, I could write my answer like this or this, but this one directly matches choice C. C is our answer. Question 38, a store buys candy by the pound. The graph shown below represents the relationship between the weight in pounds and the total cost in dollars of the candy. And we want to know, what is the cost of 1 pound of candy? Well, for this one here, notice that we have a direct proportion here, that the total cost in dollars of candy is directly proportional to the weight in pounds of the candy. So what that tells us is that we could take any point on this line, but they gave us a very specific point. They told us that this point, 6,21, is on this graph. So what that means is that the X in pounds and the Y in dollars tells us how much it costs to buy 6 pounds of candy. So that tells us that it is $21, because the Y-axis here is in dollars. It is $21 for 6 pounds of candy. So if I want to find the unit rate here for 1 pound of candy, I just have to do 21 divided by 6. And 21 divided by 6, I'll just do that over here. 6 goes into 21 3 times. 3 times 6 is 18. We subtract, and we have a remainder of 3. So I could write my remainder like this. It's 3 over, we were originally dividing by 6. Or I could just do 21 divided by 6 in the calculator, and it's going to pop up as 3.5, which matches what we have here. 3 and 3/6 is the same thing as 3.5. So I'll just make that neater. So we have 3.5, and that's the same thing as 3.5. But if I write this in terms of money, this is $3.50 per pound. So then this tells us that our solution here is choice C. Question 39, Marty types at an average rate of 25 words per minute. Write an equation that could be used to determine the average number of words W Marty types in T minutes. Now, for a question like this, students will struggle with where to attach the 25. They're going to say, is it W equals 25T? Or is it T equals 25W? And if you're unsure of which one it is, what you could do is investigate a little. So you can make a table over here with T and W. T is the number of minutes, and W is the number of words, the average number of words that Marty could type. So let's say 0 minutes goes by, then Marty types 0 words. But if 1 minute goes by and Marty types at an average rate of 25 words per minute, then that means in 1 minute he types 25 words on average. If 2 minutes goes by, we just add another 25 and we get 50. And then 3 minutes, we add another 25, we get 75. So now look at the relationship between T and W. Which one here is the bigger number, in the T column or the W column? The W column is definitely bigger, which means that the T is getting multiplied by 25. So the correct one here would be W equals 25T. So we'll just record our answer over here. We're going to say the equation is W equals 25T. Question 40, what is the value of the expression -2 times -3 times +4? Well, just know that when we multiply a negative by a negative, the result is positive. So first, let's do the product of the two negatives here. We're going to multiply -2 times -3. And -2 times -3 is going to give us +6. Okay, and then we still have to do 6 times 4. If you were unsure as to whether or not you should be multiplying or adding or subtracting, just know that in math, parentheses means multiply. So that's why we're multiplying these here, because of the parentheses. So then next, we're going to do 6 times 4, and 6 times 4 is 24. So this is our solution to question 40. The product here works out to 24. Question 41, Kenneth bought a shirt that was originally priced at $55. After a discount, he paid $38.50. What was the percent discount of the original price of the shirt? So for this question here, it really helps to know this concept, that when we want to find percent, we could think part over whole. Okay, so the percent, let's think of part over whole. So this is the concept we're going to need at the end to find the actual percent. But for now, we're starting off with the shirt is $55. And after a discount, Kenneth paid $38.50. So if we subtract the original price by the discounted price, that's going to tell us how much money Kenneth saved. So for this, if we just type this in a calculator, it tells us that Kenneth saved $16.50. Okay, so we're just subtracting these two numbers. So this amount saved here represents the part of the original price. So the discount was $16.50. That was the part that was taken off. But out of the whole price, the shirt was originally priced at a whole price of $55. So now we'll just divide these two to help us find the percent. So let's type this in. We have 16.50 and we're dividing by 55. And when we type this in, we're going to get 0.3. So to get the actual percent with the percent symbol, after we do part over whole, we're just going to multiply that decimal by 100. And this tells us that Kenneth got a 30% discount on the shirt. So we could even see here, if we do 0.30 and we multiply that by 55, notice that this matches the savings that Kenneth had on the shirt here. So the 30% is looking good. So now we'll just write this out in our workspace here. This worked out to 0.3. But remember, we wanted to turn this into a percent. So we take the decimal 0.3 and we multiply by 100. And then we could say this is the percent here. And when we work out this product, we get 30%. So the discount here was 30%. So now we're just going to write that over here in this space. The answer is 30% off. Question 42, Frank and his friends are playing a game with the spinners shown below. Each player spins the arrow 5 times and adds all the numbers the spinner lands on to get their score. Frank's first 3 spins are listed below. So he spinned a -1.5, then a 2, and then a -3.5. And Frank has 2 more spins. What 2 numbers would the spinner need to land on for Frank's final score to equal 0? And we have to explain our answer. So the first thing we could do here is just add these 3 numbers together. We could do -1.5 plus 2 plus -3.5. And if I'm doing this math in my head, what I'm going to do first is I'm going to add -1.5 and -3.5. Because remember, when you're adding numbers, the order that you add does not matter because addition is commutative. And if I'm doing this mentally, what I'm thinking of is I'm thinking of 35 plus 15. So even though we have decimals here, I just pretend that I'm adding these whole numbers, and the sum of 35 and 15 is 50. So then this would give us, we would have +2 plus -5. So all we have to do is just then move the decimal here. If I put a decimal here, here, and here, that would give us the sum 3.5 plus 1.5 equals 5.0. Okay, but we are adding 2 negatives. That's why the sum is going to work out to something negative when we simplify. And now I just do 2 plus -5 is -3. So from here, what we need to happen is the final 2 spins, we're spinning this 2 more times. The final spin, would have to be the opposite of -3, which is +3, because we want the final score to equal 0. So just look at the spinner here. If we only have two numbers that we could potentially land on that are going to make a sum of +3, the possibilities here are getting a 1 and a 2, or what we could have happen is we could get a 0 and a 3. Okay, so we have two possible answers here, a 1 and a 2, or we could get a 0 and a 3. Now, one thing I want to point out here is that in this explanation, we only have to include one of these. We could say 1 and 2, or we could just say 0 and 3. We don't have to mention both, but we do have the option to mention both of these pairs. And the justification here in our explanation after the because is that 3 is the opposite of -3. Okay, so this part here is very important if we want to get the points for explaining. We have to say why. Question 43, Joan went for a hike, and the trail she hiked was 5.5 miles, and it took her 2 1/5 hours to complete. If Joan hiked at an average unit rate, how fast in miles per hour did Joan hike? So here, the units that we need at the end for our unit rate is miles per hour. So that helps us set up the first ratio here. We're going to do 5.5 miles over, and the time that it took Joan to do this hike was 2 1/5 hours. Okay, so this is the initial ratio here that helps us find the unit rate. Now, in order to find the unit rate, we have to divide 5.5 by 2 1/5. And one way of doing this is we could turn 5.5 into an improper fraction. So we're going to do 5 times 2 is 10, and then 10 plus 1 is 11. And we're dividing by the original denominator here is 2. So we have 11 over 2 miles, and then we're over, and we do the same thing. 5 times 2 is 10, 10 plus 1 is 11, and this time we're over 5, and it's hours over here. And now we could use keep, change, flip. So we're going to keep the fraction on top. We're going to change the operation from division to multiplication, and we're going to flip the fraction on bottom. So now we have 5 over 11, and the units here are miles per hour, which if we want, we could abbreviate with MPH like this, the same way it appears in a car. And now 11 over 11 cancels out, and we're left with 5 over 2 miles per hour. Now, you get a calculator for this test, so if you want, you could leave it in fraction form, or you could do 5 divided by 2 is 2.5. So the unit rate here is 2.5 miles per hour. So let's just write that over here. The unit rate is 2.5, and we have miles per hour. Question 44, a map has a scale of 1 centimeter equals 50 miles. The actual distance between New York City and Washington, D.C. is 225 miles. What is the distance in centimeters between the two cities on the map? So for this one here, what we could do is we could set up a proportion. We know that 50 miles is equal to 1 centimeter on the map. So we have 50 miles is equal to 1 centimeter on the map. So we're using this scale here. And what we could do is we could set up another ratio where we have miles on top and centimeters on bottom. And they told us the distance between New York City and Washington, D.C. is 225 miles. Now, just know I could have written centimeters on top and miles on bottom, but whatever I commit to in my first ratio, I have to be consistent with my second ratio, that if I commit to miles on top, then miles has to stay on top over here. And the mystery value here is the distance in centimeters between the two cities on the map. So we'll just call that x for now. So we're going to have 50 times x is equal to, and then we have 1 times 225 is 225. So we just cross multiply here to solve for x in this proportion. And now to solve for x, what we're going to do to get rid of times 50 is we're going to divide 50. But the golden rule of algebra is whatever I do to one side, I have to do to the other. So I'm going to divide the right side by 50 as well. And now we have x equals, and this we could just type into a calculator, but 50 is going to go into 225 4 times, and there'll be 25 left over. And 25 over 50 reduces to a half. So I could say 4.5, or I could say 4.5. So we'll say 4.5 is the value of x, and the units next to x are centimeters. So at the end, when we write our 4.5, we could say 4.5 centimeters, and this is our final answer. Question 45, during lunch, a sandwich shop owner sold 2 types of sandwiches, turkey and roast beef. Each sandwich cost $4.99, and the total sales from all of the sandwiches sold was $219.56. there were 25 turkey sandwiches sold, how many roast beef sandwiches were sold? So for this one, each sandwich, regardless of what type of sandwich it is, costs $4.99. And let's say X sandwiches were sold. The total sales from all of the sandwiches was $219.56. And I'm going to leave the units out here because we're solving for the number of sandwiches sold. So to solve for X, we could just divide both sides by 4.99. And we do the division here. This we could just type into a calculator, and that's going to tell us X equals 44. So now from here, we can't stop here. We have to make sure we actually answer the question. They told us that there were 25 turkey sandwiches sold, and the actual question is how many roast beef sandwiches were sold? Well, if only two types of sandwiches were sold, turkey and roast beef, and we know the total number and we know the number of turkey sandwiches, then to find the number of roast beef sandwiches, we would just subtract the total number of sandwiches minus the number of turkey sandwiches sold. So we have 44 minus 25. And for this, we could just type in a calculator or do the subtraction ourselves. 19 roast beef sandwiches were sold. So we're just going to write that at the end here. The answer is 19 roast beef sandwiches. Question 46, we need to write the expression here as the sum of two unlike terms, and we have to be sure to show the use of the properties of operations in our answer. Show your work. So for this one, I'm just going to recopy here the expression that we're starting with. We have negative 8 times 4 minus x and then plus 20 outside of the parentheses. So first, we're going to use the distributive property. We're going to send the negative 8 through by multiplication. Negative 8 times 4 is negative 32. And then we have a negative times a negative, which is going to go positive, and 8 times x is 8x. And the plus 20 just tags along like this. And now we need to express the expression here as the sum of two unlike terms. So right now we have 3 terms. We need to narrow this down to 2 terms. So we're going to combine like terms. We're going to add these integers here. So in our final answer, we're going to have 8x. And then if we do negative 32 plus 20, that's going to give us negative 12. The math that I'm doing in my head is instead of doing negative 32 plus 20, I'm doing negative and then in parentheses 32 minus 20. 32 minus 20 is 12, so we get negative 12. And now we can just record our answer. Question 47, Jonah received a gift card to a movie theater. The gift card allows him to choose one type of movie, one snack, and one drink. His options are shown in the list below. So movies, he could choose from drama, action, or comedy. So that is 3 options. For snacks, there's popcorn, chips, candy. So that's 3 options. And for drinks, he could get water or juice. And that's 2 options. He chooses one movie, one snack, and one drink at random. What is the probability that Jonah chooses a comedy, chips, and juice? And we have to write our answer as a fraction. And we have to show our work. So for this question, if you know the multiplication principle, then this question can be done very, very quickly. So the number of possibilities here, for movies, there are 3 options. There's drama, action, comedy. And then we multiply by the number of options for snacks. And there's 3 options for snacks. We could have popcorn, chips, or candy. So that's times 3. And then we multiply this by the number of options for drinks. And there are 2 options for drinks. So now we work this out. 3 times 3 is 9, and 9 times 2 is 18. So we look at the specific combination here that Jonah chooses a comedy, chips, and juice. What's the probability of that happening? That's just 1 out of the 18. Okay, so we could just say here, this tells us the probability is 1 out of 18. But if you really want to see the concept here, what you could do first is you could just list everything. So we could start off here with movies, and we could see that there are 3 options for movies. There's drama, action, comedy. So I'm going to say drama, action, and comedy. And then after the movie is selected, we're talking next about snacks. And there are 3 options for snacks. So for this one here, I'm just going to make a tree diagram like this. So there's 3 options for snacks, and it's popcorn, chips, and candy. And I'll just throw in 2 letters so that it distinguishes, the listing here from the original listing of comedy. So we have popcorn, chips, candy. We have popcorn, chips, candy. And then from here, there are 2 options for drinks. There's water or juice. So now I'm going to draw 2 branches coming out of each of these, and it's going to be water or juice. And we could do this all the way down. So now we can look at this tree diagram here and see that comedy, chips, and juice is just one of the final branches. So I'm just going to highlight it here in red. So comedy, and then to chips, and then to juice is one of these branches. And how many branches are there at the end? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so this is just one branch out of the 18 total. So the probability we're going to write here is 1 out of 18. Question 48, a furniture store is advertising a 20% discount on the price of sofas. Scott chooses a sofa with a discounted price of $460. He must also pay an 8% sales tax. How much money will Scott save on the discounted sofa, including tax, compared to the originally priced sofa, including tax? So for questions like this, I really like this idea about percents. That when they tell you the discount, in this case, we're getting a 20% discount. I like to think of it as the percent off versus the percent on. So if we're getting 20% off, do 100 minus 20 is 80. And that tells us that 80% of the original price is still on. So when I'm setting up an equation here, I could say 80%, which now let's talk about 80%. 80% is 80 out of 100. And 80 hundredths is 0.80. Or I could just say 0.8. So we could say 0.8 times X, and this represents 80% of the original price, and 80% of the original price works out to the discounted price of 460. Okay, so this is just a nice way of setting up the equation. So from here, if we want to solve for the original price of the sofa, we're going to divide both sides of this equation by 0.8. And this we could just type into a calculator. And that's going to tell us that X is equal to 575. And I'll make this a little bit neater. We have X is equal to 575. But they want us to see how much money Scott will save on the discounted sofa, including tax, compared to the originally priced sofa, including tax. So one thing now we have to account for is that the tax is 8%. So when you have a tax of, let's say, 8%, a nice way to add the tax on is you could just think here 8% is 8 over 100. And this works out to 0.08. This is 8 hundredths. But when I want to add the tax onto something, what I could do instead is I can use the 0.08, or I could just say here, I'm going to multiply that price by 1.08. Okay, so the shortcut is to just do times 1.08. So I'm going to take 575 and I'm going to multiply it by 1.08. And we do get a calculator for this part, so we could just type this in a calculator. And if we work this out, this should give us $621 even. And I'm not going to write the units here. I'm going to write the units at the end, or the answer space, they're going to have the dollar sign for us. And next we have to look at the discounted price with the tax included. So the discounted price was $460, and we're multiplying this by 1.08 as well. So when we do this times 1.08, we're going to get 496 and then 0.80. So now all we have to do to find out how much money Scott will save is we have to subtract these two numbers. So we're going to do 621 and then minus 496.80. And this is also calculator work, and we get 124.20. So this is our final answer. We could just write this over here. Scott will save $124.20.